Go ahead and stand up when you have this copy down. All right. So today we are starting with distributor property. Now, I'm gonna be honest with you. Distributor property is not hard. We as students like to make it hard. Okay? So when we are going through our notes and our practice today, if you do not understand something, guys, I need you to raise your hand to be like, Miss Kinney, can you explain it again? Or can you try to explain it a different way? This is super important, and this goes on to 7th grade, 8th grade, 9th grade, and so on and so forth. So this is not something that goes away. And my 8th graders that I have now still struggle with distributive property. All right? Not because it's hard, but because it's that simple. Like, it's too simple. Like, to me, it's one of those things that just, yes. And it's a very simple concept that obviously when we throw in variables and we throw in negative numbers, then our heads explode and we forget what we're doing. But the basic skill of distributive property is the same no matter what your numbers are. Okay? All right, so to start with, we're just going to get warmed up. This is not distributive property. It says each student below simplified the expression as shown. So you have Miguel, you have Elise, and then you have Francis. The question says, if x equals 3, will Francis's solution be the same as Miguel's and Elise's? Explain why this might be. All right, so I want you guys, they've already solved Miguel and Elise. You have to solve Francis and see if it's equal, if it's not equal, and tell me why. Okay, when you have this done, stand up. I'm gonna give you 3 minutes max. So, question, how many of you have forgotten what we do when we we have the value for our variable? How many of you have forgotten what to do with it? Thank you, Alex. Thank you, Summer. Thank you, Gabriel. So, we have x. We have an unknown number, right? Yes, no? All right, down here, it gives us the value for x, right? So this is where you have to do that substitution. If it gives you the value, you're taking x out and you're plugging 3 in. Now, what do those parentheses mean? Ansley? Multiplication. All right, that is all I'm doing to help you. From there, you should be able to answer this question. When you are done, you should be standing. has got 50 seconds left. 50 seconds. All right, so when we plug in our 3 here, we do 6 times 3 plus, is it 6 times 9? 6 times 9. So then down here, they give you this answer, right? But then they do 6x. Well, we know what x equals. Well, so what is 6 times 3? What's 6 times 3, Dre? 18. And then from here, we do 18 plus 54. Raise your hand and tell me what is 18 plus 54, Gabe? 72. So, can we answer the question? If x equals 3, will Francis' solution be the same as the other two? Why do we know? Or why might this be? Like, why? Ansley?
Because 6 times 3 equals 18, and add 18 plus 54 is 72.
Okay. That's right. 100% right. But what's a simpler reason? Look at the other two. What did they do? Does anybody see something that is similar in the first two, that when we plug in 3 to our answer, we get something? Or we plug in 3 to the last one? Fine. Get something. Ansley, do you see it? So do they multiply 6 times 3 in the first one? Do they multiply 6 times 3 in the second one? Are you sure? What does parentheses mean? So did they multiply 6 times 3? And then in the last one, did we multiply 6 times 3? So essentially, they're multiplying 6 times 3 in every one of these, right? And 6 times 9 in all of these. So your answer, there's no right or wrong answer. I'm not going to write an explanation for you guys because, I mean, it's as long as you're seeing that there's a pattern that we're doing the same thing for each one of these, that's the pattern we want you to see. But you do need to write yes, because whatever. Okay? All right. Let's get down to distributive property. So distributive property allows us to multiply each term inside, please make sure you write that in capital letters, parentheses, by the number outside, again, write that in capital letters, of the parentheses. So you are multiplying the numbers on the inside of parentheses by the number on the outside of the parentheses. The key thing is multiplication. You've got to know you are multiplying. Write this down, son. There's no reason you're sitting not writing. All right, algebraically, we would say A times B plus C. So that's how you would say that. Now, if these were numbers, we'd say 3 times 4 plus 7, or whatever the numbers are. But to say this, the parentheses do not mean you do that first. Parentheses when you're doing distributive property means multiply. So over here, somewhere on your paper, I want you to write parentheses equals multiply. So when it says distributive property, your parentheses are not what you do first. It means you're multiplying. That's going to be the hardest thing for us to to separate. So this actually becomes, and I'm going to put it in parentheses, A times B plus A times C. Are you going to zoom in? Maybe? No. Now, how did I know to put the plus sign there? Everly, maybe you should move closer, baby, so you can see. Then stop straining to see. So how did I know to add? Hayden.
Because in original problem, it has an addition sign. If you're trying to make it a different problem, you can't leave out anything. So you have to bring the addition sign in. And since it was originally B plus C, you have to bring A times B, and A times C, you have to add this together.
Right. So short version, whatever this is, goes in between the two. So this one is subtract. So what's going to go in between the two over here? Subtraction. All right? That does not mean that it's going to be a negative number. It just simply means you're subtracting the first multiplication from the second multiplication. That's it. Now, we're going to write this one a teeny bit different so you see it. So this one is going to be A times B minus A times C. So what is the difference between the first one that I wrote and the second one I wrote? Don't tell me addition or subtraction, because that's not what I want to know. What's the difference, Zach? The parentheses are different. On your tests and quizzes, you're going to see it this way. Okay? You're going to see it this way. You have to understand that this is A times B, A times C. That's what this means. This also means A times B, A times C. Okay? So number on the outside multiplied by all the numbers inside your parentheses. It's not always going to be 2. You could have 3. You could have 4. How many of you guys have done this on Delta Math this week? Would they go up to 3 or 4?
I think it was 4.
4. So you had 4 terms on the inside of your parentheses, and you had to multiply that outside number times each one of those. Doesn't matter if there's 18 numbers inside. You're multiplying it by 18. Okay? All right, let's do some practice. Oh, sorry. Be careful with, I forgot that last one. The sign when multiplying integers. Integers are just numbers, by the way. So it says each of the 4 members of the Robinson family ordered a drink, 2 slices of pizza, and an ice cream cone. So we have 4 on the outside of our parentheses, and then we technically have soda, 2 slices of pizza, and 1 ice cream. So we're going to do D for drink, we're going to do P for pizza, and C for ice cream. So those are going to be our variables. And then you are going to do this for every problem you do today. All right? Those little arrows tell me that I am distributing the 4 to from the outside to the inside, outside to the inside, outside to the inside. So this becomes 4 times what? 4 times what for the first one? So 4 times, what's our variable? Drake.
4 times 1.
Not 1.
4 times D.
4 times D. All right, the next one. Be careful with this one. Be careful. So this is 4 times what? No, it is not P. And that's why I said be careful, because how many slices of pizza did everybody order? Plus there's how many slices of pizza? 2. So we need to make sure we do 4 times 2P. And then the last one, how many slices or how many ice creams did they get? 1, so it's 4 times C. So when I rewrite this all together, I get 4D plus, what's 4 times 2? 8P plus 4C. questions? Feel okay? Okay. All right. I despise the area model, but the area model is so good when you're doing distributed property if you struggle with it. Because to me, this separates it, and it just essentially creates two of your problems that you have to essentially solve. Yes?
It showed those are the example of the
Right. Yeah, I mean, and I apologize that it came sooner in your Delta Math than when we got to it. We were supposed to get to it yesterday. But anyways, for the most part, this is not hard at all. It's just a lot of multiplication. So when you're doing the area model, you essentially are doing 5 times 3x, and you're doing 5 times 2. And like I said, I don't care for the area model, but this is really good for distributed property. All right, and why do I know that I'm doing 5 times 3x here and 5 times 2 there? Zach?
The variable in 3 and there's no variable in 2.
Right. Well, there's no variable in 3, there's no variable in 2, but it's also, this is what's on top of this side of the box, this is what's on top of this side of the box. So when I do 5 times 3, what do I get? What do I get when I do 5 times 3? Samantha?
15.
And then I just throw in my x. And what do I get when I do 5 times 2? Angel? 10. So this becomes 15x plus 10. And how do I know it's a positive 10? Like, how do I know it's plus 10? What do you think, Alex?
Because there's no negative sign.
Because there's no negative sign. So there's no negative sign, so I know that this is a positive 10. Does that make sense? All right, the next one. 7 times x. And the reason I'm not putting a times symbol with an x is because it looks really weird. It's like 7xx. And then we have 7 times negative 9. Do not lose your minds with this negative number right here. Okay? That negative simply means that we're going to be subtracting. We're going to treat that negative as an indivisible symbol right now. And we're just going to look at it as 7 times 9. Okay? So what's 7 times x? What is 7 times x? Kaden?
7.
Huh? No. What is 7 times x? What does that become?
7.
Angel?
7.
Huh?
7x.
Yes. So 7x. Now, I know that that means I'm going to subtract because this is a minus. So I'm going to put my subtraction there, and then that should not be, oh, no, that's right, sorry. 7 times 9 is what?
Actually, no, it's 60.
Hurry up.
60.
Kira?
63.
Yes. Okay, so that is how you deal with that negative 9. It's not, I don't think you'll see any other negatives like that today. All right, questions about those two? Feel okay? Again, you're multiplying the number on the outside by everything on the inside. All right, slide up to the top of the right page. So it says practice distributed property by writing the expression in expanded form and then simplest form. Now, we're not solving, we're simplifying. So again, this is a simplification. I love that word. I don't even know if it's a real word, but I'm going to make it a real word. This is a simplification of a big expression to a small expression. Okay? So we're going to do 2 times x and 2 times 6. So on this line where it says expanded form, you're going to write 2 times x plus. How do I know I'm plussing? How do I know I'm adding? How do I know that that is a plus sign? Gabriel. I think you mumbled out there's a plus in between what?
Like up there.
Yes, there's a plus up there. And then 2 times 6. Now, does everybody understand why I put this dot and what that dot means?
Yeah.
Is there anybody that doesn't know what the dot means?
No, I
Alright, and guys, the reason I put a dot here is because of this. Again, it would look really weird to write 2xx, and I don't want you guys to get confused. Alright, so what is 2 times x? What does that become? Drake? 2x. I'm going to bring my plus sign down, and then what is 2 times 6? Samantha? 12. That is literally how easy this is. It's not hard at all. All right, the next one. We're going to distribute our 7 in, and we're going to do 7 times 5 plus 7 times p. So go ahead and write the simplified form of 7 times 5 plus 7 times p. And then give me a thumbs up. The simplest form. So just like we did here, you're writing it the same way over there. No, just thumbs up. All right, what is 7 times 5? What's 7 times 5? Silas H. You said 35? Okay, and then I bring my plus sign down, and what is 7 times p? Summer? 7p. All right, the next one, number 5. What changes with number 5? What changes?
Operation, not subtraction.
All right, but does that affect what we do?
No.
No, it does not affect the process. The process is still the same. So I'm still going to distribute my 8 into both of those. So I'm going to do 8 times 7 minus 8 times g. All right, again, write your simplified answer and then stand up for me this time. All right, Reagan, what'd you get? 56 minus 8g. All right, last one. Go ahead, write it in your expanded form, write it in your simplified or simplest form, and then stand up for me. You good, Christian? Yeah? Oh, hi, friend. Hi, friend. I'm just collecting all kinds of things. I got stuff from you. I got stuff from... Is it you? Does that look like you? I don't either. How did you leave your entire life here with me yesterday? What? Your whole life. You left your phone, and I did not see an extra pencil up there. So I will fight you today if I don't find my pencil. Considering you left your phone and stole my pencil.
No, I'll put the pencil back, but I forgot my book.
You're so silly. Bye, Sebastian. All right. Oh, what'd you get? Like, what is my expanded form? You got it. So what do we put inside our first parentheses? You got it. 12 what?
12 times R.
Perfect. And then is it minus or is it plus? Okay, and then what goes inside my second parentheses? I can't hear. 12. Guys, stop so I can hear her. All right, what goes in the second one? You got it, baby. Yes. And if y'all don't stop moving over here either, chill. All right, so we have 12 times R minus 12 times 9. Raise your hand and tell me, what is my simplest form? Ansley.
12R minus 108.
All right, how do we feel about distributive property? It is not hard, guys. It's multiplying on the outside, multiplying on the inside. All right, you guys as a group are doing 7, 8, 9, and 10. Stand up when you finish.
It's actually not. Oh yeah. There we go.
You should not be talking about social studies.
What are you talking about? We're not
Exactly.
No. Miss Kitty, do you like algebra?
I love all math, but algebra to me just makes sense. Sometimes, I mean, what else are you gonna put? You can put pictures, but pictures get.
Just don't create algebra.
You have to. Algebra is
Not useful
technically.
at all.
That's not true. Not true at all. That algebra applies to real life a lot more than other things that we learn.
Does it apply to living? Does it apply to my job?
Are you finished? Then stand up and be quiet.
Oh yeah, but that's not.
Say they did not multiply 8K. Now we gotta
You need this one too. All right, you guys have 10 seconds. All right, have a seat. So for number 7, what goes inside the first set of parentheses? All right, Drake.
5 times 3x.
All right, what goes in between the parentheses?
The plus sign.
And what goes in the last one?
5 times 10.
All right, and I hope you guys realize, just like when we were doing, like adding and subtracting when we were combining like terms, you're only multiplying times the number. You're not multiplying times the variable. So we have 5 times 3, which is 15x, plus 5 times 10, which is 50. All right, the next one. Raise your hand and tell me what goes inside the first parentheses. All right, Silas.
3 times x
So 3 times x, what goes in between them?
plus
And what goes on the outside?
3
Or
times x.
the other one. 3 times 4. And what do you get when you simplify?
3x plus 12.
All right, and then the last one. All right, Ansley.
12 times 6 in parentheses minus 12 times 2x in parentheses, and then you get 72 minus 24x.
All right, how did we do with that one? Or those, sorry, not that one. Okay. All right, so number 10, it says there was these 3 problems written on the board. There was a mistake made. So which one is the mistake? The first one, second one, or third one? Raise your hand and tell me what that mistake was. All right, Alex.
It was the third one.
Okay, and what was the mistake that was made?
The 7 times 8, they didn't multiply it, they just brought the 8 down.
Right, so it becomes 63 minus what?
63 minus 56.
Okay. All right. Go ahead. Put this to the side. Don't glue it in yet. You're going to slide over to the right side. And you're going to title it Distributive Property Notes and Guided Practice and get the little half sheet out that I just passed out to you guys. You don't need to talk. Just get it done. All right. So the top says, it gives you the definition of what distributive property is. Distributive property is when multiply a sum by a number. You can multiply each add-in, which is just simply each number being added by the outside number. And it creates an equivalent expression. So all the expressions that we just converted to simplest form on the note page is equivalent to the original. So they give you 2 examples of different ways to solve. This is the way that I teach you. This is the distributive property way. Now, they do give you this way, which could make sense to people, could not make sense to people. It's just simply saying that there are 5 groups of x plus 3. So that's this way of thinking it. This is not the distributive property way. You're not going to see it this way anywhere on a test or quiz or anything. But if this way doesn't make sense, maybe this way will. I don't know either way. But I did want to show you that. Now, we're going to skip these 4 for a minute, and I want you guys to go down to where it says factoring expressions. Yesterday, on that assignment, slide 10 talked about finding the GCF and then using that to help you with distributive property. So factoring expressions is where you can create equivalent expressions by pulling out the greatest common factor. You're gonna need to know how to do this, and we go in depth one day specifically about using GCF, but I want you to be exposed to it. So here, their example is 20x plus 12. They found the GCF to be 4 of both of those. You put your GCF on the outside, and you say to yourself, okay, well, what do I multiply 4 by to get 20? You multiply 5. What do I multiply 4 by to get 12? All right, I have a trick that to me makes it a little bit easier. So we're going to do this one together. You have 18y plus 6. We are trying to find the GCF of 18 and 6. So I'm going to do my tall t. And I'm going to write the factors. And everybody is going to write the factors for 18 and 6. So you have 18 times 1, 2 times 9, 3 times 6. For 6, I have 1 times 6, 2 times 3. Thumbs up when you have that written down. All right, this is nothing new. We've talked about GCF. We spent a good deal of time on GCF. Now, which one is the greatest common factor in both 18 and 6? BK. All right, so I want you to circle the 6 in both of them. And then I want you to highlight the number that you multiply next to. All right, so our 6, which is our GCF, goes on the outside of our parentheses, right? So I'm going to put 6 here, and then I'm going to put my parentheses. Now, 6 is on the outside, and this is the trick that I feel like is super easy when you're doing bigger numbers. Obviously, these are very simple numbers. The numbers are not always going to be this nice. The number that you highlighted are the 2 numbers that go inside of your parentheses. So when I'm finding 18, it automatically gives me the number that goes inside. I don't have to think about anything. And then over here, it gives me that number. So as long as I do this correct, I'll get those numbers correct. Does that make sense? Yes or no? Because 6 times 3 gives you 18. 6 times 1 gives you 6. Again, it's just a trick. Maybe it works, maybe it doesn't. Maybe you're like, that doesn't make any sense to me. And that's fine. If it doesn't make any sense to you, don't use it. Just do what you did yesterday or what they did here. You guys, as a group, are completing 1, 2, 3, and 4. When you are done, you're bringing your papers to me. If everything comes out and you did it correctly, you're getting your homework. If not, I'm sending you back as a group and you got to fix them. Yeah.
So you want to do the way?
No, these are all the way we practice. Hold on, guys, stop for a second. So these are all the way we spent all morning practicing. These are not GCF. Okay? So 1, 2, 3, and 4, you can just use, if I can pick it up, this sheet to help you. All right? So it's not the GCF way, it's just this way. All right, go ahead.